All right, we're going to go ahead and get started then. Thanks everybody for jumping in on the Atomic Friday webinar. A couple of references for what we're going to be talking about today. We've got trusted developer tools from MITRE. We're going to go through a couple of these, share some of what Ross from Endgame and I shared at Black Hat. And atomicredteam.io is a good place to get resources if this is your first time attending an Atomic Red Team. And these are recorded, so I did put a reminder in myself on the slide to hit record. I forgot that in the past. So really, these are our observations. This is a time to have fun, ask questions, keep it interactive. It's not like maybe a traditional webinar or product pitch, but we do think at Red Canary it's important for all teams to help improve their security. So we get a chance to do these on Fridays. And thanks for coming out and joining us. So a couple of things about what we're going to be talking about today. My name is Casey Smith, Director of Applied Research at Red Canary, and worked on the Atomic Red Team with Mike. And Mike is on. I'll let you do a quick intro too, Mike.
Yep, thanks. My name is Mike Haig. Director of Threat Research here at Red Canary as well. Casey and I work together here on Applied Research.
Yeah, there's the important ball game we snuck out to earlier this week at the Rockies game. So very important stuff. So very good. Okay. So what are we talking about this week? Why do developer tools matter? What you need to worry about? There's a lot here, and there's a lot of abuse potential for developer tools. And so we want to make sure you at least have some guiding principles. Two that we're going to dive into deep, Debug Serve and MSBuild. So MSBuild you've probably heard of before. Debug Serve is a fairly new tool that can be abused to do remote shellcode delivery and execution on a target. So although the nice thing is that one's pretty rare. We'll do a quick demo. And then as you have questions, again, a couple of references, atomicredteam.com. If you're interested in previous recordings we've done, and I think we're all set. So the only caveat is my dog is in my office today. So if the doorbell rings, I cannot be held responsible for the noise. I'll just hit mute and flip it over to Mike.
So atomicredteam.com will lead you to all of our prior content from Atomic Fridays and anything else related to Atomic. Plus you can get to the GitHub repo from there.
Yep. Yeah. So again, that's where kind of a good landing page. We also have a Slack channel. A lot of people like to join in there, ask questions. It's pretty hyper-focused on just atomic testing. So happy to join us over there. So, okay, so let's dive in with T1127. So those of you who are familiar with MITRE ATT&CK will recognize the ID for these. The trusted developer tools covers a suite of different capabilities and developer tools that can be used. Again, one of the things that's important to call out is the way that MITRE ATT&CK and Atomic Red Team are related. MITRE ATT&CK owns the content. They own the taxonomy for the various attacks, and we've mapped all of our tests back to this. So when you're asked questions about do we have coverage for developer tools, then Atomic Red Team can help you maybe go exercise some tests. So there's a few other researchers that have committed to this. Matt Nelson, Matt Graber. There's a couple other trusted developer tools you'll find there, like DNX and some F# execution, as well as using debuggers in a malicious way. So pretty interesting use case that's pretty broad, like you'll find with MITRE ATT&CK. Sometimes there's a lot more here than maybe just what you're seeing. But remember the data sources for MITRE ATT&CK. We'll cover those later to be able to observe this particular technique. So, okay. MSBuild. So this is a good one. Some of you are familiar with this probably, but it's good to go on the record, we think, just to make sure people understand what this tool is. It's specifically called out in MITRE ATT&CK, and we want to understand, like, how is it used and what does it look like when an attacker may use this in a bad way. So a couple of things about this. So first of all, the Microsoft Build Engine is a tool that a developer would use to compile their code, quite simply .NET code, right? So it's default on everything Windows 10 and above. It is specifically the version that you want to watch out for is the one related to .NET 4.0, 3.03.19 or above, because that is the one that has a particular feature that can be abused to evade whitelisting or other components. There's a lot more here than just like running C# code inside of MSBuild, and we'll take you through those examples. So any questions on that, like as far as that, where it is, or what systems it may be on? Hopefully that's pretty clear.
Yeah, Casey, can you actually tell us the full path that it's in off
Yes.
of memory?
Yeah. So C, Windows, Microsoft.NET, Framework V40303119. You may need either Framework or Framework 64, depending on your shellcode payload. So watch out for that for those offensive operators that are watching today. So, yeah. I do know that path well. That'll actually come up later because most of the time, developers, when they're running from Visual Studio, it's not in that path, right? So that's an important hook to come back to. So, all right. So what's the big deal with MSBuild? Why do we care? First of all, this version that ships with .NET 4 has a feature called Inline Tasks. Now, that's the one that's probably the most widely used in terms of you can enrich the build process with C# code fragments. So why in the world would you do that? Well, think about tasks that a developer might need to do when they're building an application, like maybe I need to create some directories or write some loops or do some signing. So you can automate a lot of these tasks in C# much easier than other like batch scripts or even JScript or VB script. So inline tasks really give you the full Windows API inside of your build process. And so there's 3 things you need to know about that. There can be either fragments or modules or entire class structures. Those of you familiar with C# that can actually execute the code. So it's an incredibly powerful way to use MSBuild. I'll show you an example. That's really what our tests are designed for. Now, 2 other elements of MSBuild that you need to be aware of, there are other tasks. And so you'll see at the bottom of this page, I put the reference. There's like, I think, over 30 different kinds of inline, not inline tasks, just tasks in general. So for example, there's a task called exec. Okay, so if you want it to, run another program as a part of your build process, then you would call exec. It would show up as a child process of like cmd/c or whatever you're running, but that's like a very simple way to proxy execution. Furthermore, if you look over in the right-hand column, there's a bunch of other tasks. So things that like download a file, copy files, register. So it's a really powerful suite. All of these tasks can present different behaviors that you may want to watch out for. But specifically, we're going to focus on inline tasks, and that's what our atomic testing is. So let me pause there. I was talking for a bit. Any questions on like the background before we dive into the actual atomic tests or code?
Doesn't look like it yet.
All right, sweet, very good. Okay, so what does an atomic test look like as it relates to MSBuild? So we use a project file. So you can see here T1127 with a CSPROJ file. The markdown files that are in atomic are really just for teams that are going to do copy and paste and run the code later, maybe by the command line. And then we have an example of a YAML file that actually describes the test. And we'll talk about that in just a moment. Again, all of the references there for GitHub or additional information at the bottom of the page. I think the thing to be clear on this is that the extension doesn't matter. So it's really just an XML file, right? So if you're looking at an inline task, what matters is that the structure is followed by your code that's going to run this. So if you look at line 3 here, for example, we can run MSBuild and then the name of our file, and it will execute then our C# code in this situation on line 18. So for all of our testing, there's a couple of interesting observations here that Mike will talk about. One will come up later related to line 12, the DLL, and then the other one would be MSBuild creating these class files, C# files, and dynamic DLLs. All the atomic tests are really pretty benign, but you can obviously be very aggressive and add additional tests. So think of MSBuild as like a C# script host, I guess is probably the easiest way to think of that tool. And that's why you really need to pay attention. Now, the one that we're describing that's default for the OS is in the path you see on line 12, that framework folder, but there could be other locations that may be important for your organization. So I think, let's see where we're at here. So hopefully that kind of shows you like how MSBuild is used for inline tasks, how you can use it for creating code fragments. And I'll let Mike take it away for a minute and talk a little bit about, so what are the detection ideas or things around the use or abuse of MSBuild?
Yep. And so this is probably one of the more interesting processes to go hunt for in any organization. MSBuild can be extremely noisy. If it's writing DLLs, all the CSC processes, the C# compiler, that piece is very noisy as far as file mods go and paths it's using. Everything can look evil until you realize it's just a developer doing their job. Or even a, what do you call it? Like one of these build servers generating binaries all day. They're extremely noisy. So it kind of comes down to who's actually using MSBuild and what's not normal with MSBuild. And fortunately, it's been out there long enough to where we can all go and like look at past tweets and past research on MSBuild, that you can easily start to build out your content, your use cases, looking for abnormal for MSBuild. So looking for URLs in the command line, MSBuild performing network connections, it's spawning off of Word or any kind of Office product. And so looking for all those different process ancestry pieces, and or even if it's just being renamed, you might find instances where you need to just look for original file name of msbuild.exe. And it's just all part of the process. And when you're just baselining MSBuild, it's potential just for a hot mess. You might find everybody's using it, and then you might find a couple where it's a little bit more one-off, and that might be your most interest one. Casey, if you want to talk about that path piece there at the end.
Yeah, so that I had mentioned that earlier. So when you were like kind of trolling me about the framework path, like that one, so the Windows Microsoft.NET path is the one on the OS. Program files is actually where you find Visual Studio installed, and that's actually where you often see MSBuild running from in a development process. So that's kind of the nuance there. I just wanted to call out, like on a depending on the employee's role, they may not ever need to run MSBuild in the first place, and if they do, it may run from an approved or sanctioned path. It still has the capabilities. Be aware of it. Like there's opportunity for brittle detection if you only focus on the .NET folder. I think that's another thing to call out here is like find where MSBuild lives if it's been renamed, and just make sure it's approved execution. So that's kind of why I put that in there, Mike. So.
Yep. Yeah, totally cool. And even the command line piece, the absence of it, and I think we saw that recently where there wasn't any command line to it, and it was, I'm trying to think of how to say that, but
yeah, like a normal build command line is going to have like maybe like 15 to 20 parameters, right, to influence the build. Like,
yeah, there you go.
Copy the files and all that stuff. So like that's kind of the piece there is like, if there's MSBuild without a command line or varying from your organization, that may be a key too.
Yep. Yeah, just seeing it execute with like, say, a project file out of like downloads is probably going to be interesting. Or CTemp.
Yeah, and I think when we first found this, like a few years ago, like Windows 10 wasn't as widely deployed as it is today, and so I think you'll probably continue to see an uptick in usage, because as adversaries move away from PowerShell because of logging, this makes a really natural place to execute .NET code dynamically. So, yep.
Excellent. And something we found, and I think it's been out for a little while now, this does come from Microsoft. This is called Aaron Locker. It's a really great way to use App Locker. And he provides lots and lots of documentation. There's a whole guide on how to use it. There's a couple of videos that they've produced on it. And this allows you to use PowerShell, group policy, everything you need to centralize the management of App Locker. And it's way in depth, but they do provide lots of, like I said, mentions of the documentation on how to use it. But this can help you lock down MSBuild across your organization. And he also goes further. There's obviously the whole list for Microsoft, like DNX and CSI, lots of those different other developer binaries that you can use Aaron Locker with to begin to lock down across the organization. So if no one's using it, or there's limited use within your org, you can use something like this to push out App Locker policy and lock these processes down. It's obviously not going to prevent everything. It's not, like a straight app whitelisting utility or anything like that, but it's definitely something that will at least help you get on your way to prevent the use of these items.
Yeah, and I think even we didn't put it on this slide, but even like process logging, sysmon, if you're not doing those type of things, even app locker logs can be really a rich source of this would have been blocked, even if you're worried about causing a block in a production environment. It can really, like, you may want to investigate, how often is it running, and there's an easy way to meter that. So.
Yep. Yeah, just the auditing piece. Yep.
Yep. Yeah. Well, so we had a good question come in. Someone asked kind of about, like, is MSBuild basically like GCC for Windows, or where is it located? And so to answer that question for everybody, it is like GCC in terms of like the compiler. I think what makes it a little bit different is some of the really rich tasks and like how it augments the build process in a way that an adversary could use. They don't, like, adversaries aren't actually trying to build a package. They're just trying to get their code to execute an assigned binary. So that's maybe the distinction there. Yeah, so that's a really good question though. So cool. I think we're getting ready to switch gears from MSBuild. Are there any other questions on MSBuild or how that's used before we switch gears into another trusted developer tool called Debug Serve? Everybody okay? I think so.
Yeah.
They say you're supposed to wait 5 seconds to let people formulate questions. So. Because you're like, any questions? Next. Okay. All right. So what about something you've never seen before? And this was really fun. So Ross and I did Ross Wolf at Endgame did a talk at Black Hat. And so this is a little bit of review of some of that for those of you who may have missed that talk. So a huge shout out to Ross. That was super fun to present. But what may be coming next? Oh, it looks like Ross is on. So awesome. So pretty cool capabilities here. Debug Serve was a scenario that Ross and I take you through in the Black Hat talk about, like, how do you hunt or find things you haven't seen before? So Debug Serve is a remote process server. It is not default. That's one of the cool distinctions. There is the ability, an attacker may need to bring it, but if they're targeting a developer workstation, it may already be there. So it actually can receive, so think like bind shell. You could connect to a remote target, or you could actually do like a reverse TCP connection and connect out. And a lot of organizations that trust software based on a publisher or signature may miss this tool because it's signed and trusted. So really cool reference. Ross and I put together a link for the bit.ly link at the bottom there if you want references from the Black Hat talk, slides, and some of the analytics we're going to go over in this one. So a little bit of rehash. I know not everybody saw that, so just wanted to make sure people understood. It's kind of a fun thing to talk about with developer tools. So think of this tool as a way to give you a reverse TCP connection. With debuggers, you can attach to processes. You can spawn child processes. You can inject code. You have really full control of not only the application, but all the registers, memory locations, allocation. So it's kind of a really neat way, primitive, to control a remote target. Reminder though, this is not an exploit. In terms of, this is the way the tool is designed to be used. So that's what we're trying to understand. Is Debug Serve running in our network? Is on which machines, etc. So
I was just thinking about this, Casey. Do you remember that process waitfor.exe?
Oh yeah, yeah.
I just thought about it. I was like, this really reminds me of that in a way. Setting one machine to listen under wait for, and then having another machine just send the command, and it's just listening on the wire to pick it up.
Yeah, that I forgot about that. Yeah, wait for is kind of like that. Like this could be actually. So we've talked about connection proxies before, right? Things like local tunnel. So you could actually set up a Debug Serve listener and then a local tunnel, and then you have an outside-in connection. Is very plausible for attackers to use, kind of like wait for. It's just sort of sitting there waiting for an inbound connection. Yep.
Yeah, pretty cool. That's interesting. Good.
Okay. All right. So how does this work? This is kind of neat. So here you have like the server side at the top would just set up the CDB, which is a command line debugger. In this situation, we're going to listen on port 22, and we're going to spawn the child process notepad when we get a connection from our target. So this is the receiver. The client side then is going to make an outbound connection using the CL icon. And that can either be a domain name or IP address, and then the port number. There's other protocols here to be sure, like SSL, TLS. There's named pipes. There's a lot. In this situation, we're just going to do a straight TCP call. So let me just set up the demo so people kind of understand what they're seeing, and then I'll run you through the demo. So Debug Serve on the client side is going to run first, and then we're going to connect secondly to the target, and then last we're going to make a shellcode connection back to our Kali server. So there's 3 systems in play in this demo I'm about to show you with this tool. So let me, oh man, Ross, there we go. I practiced this so much for Black Hat. He'd be so proud of me. It's so smooth. So, so there we go. So here we're running just Metasploit, and we're just setting up our listener, and we're just going to go ahead and do something to receive the shellcode using MSF console. And here is the target system where we're going to run Debug Serve through JavaScript. And then you can see right now Debug Serve or Notepad, neither one of those are running. And then we can see the debugger waiting to receive the connection. So we're confirming the server's ready to receive the callback. And as you guys are going back through this, we'll talk about, but like the syntax, but in the talk, Ross and I was trying to hide from Ross, so I used a COM object to broker my execution. And so here you can see, like, I run the JScript file, and then I see Debug Serve running, and now Notepad has spawned process 4380. Those of you familiar with debuggers will recognize the callback there. So let me pause for just a second. So dvalloc is going to let us allocate read, write, execute at the target. That's built in. It's nothing new or novel there. All of this can be scripted. I just did copy and paste, so it was really clear in the demo what we were doing. And so now I can read that file, my shellcode file, into that offset. So think the server is downloading the code to the target and then changing the instruction pointer to the new location. So that's pretty powerful, primitive. And now we get a callback. If you look, you see Notepad's running, and you can see we got a callback to our Kali box interpreter shell. And so kind of fun, terrifying. And you can see we can confirm our PID. There I am in Notepad, and we can see we've got a full interactive like interpreter session in Notepad. So that was one of the fun things we showed at Black Hat. But what's more powerful, I think, is like, how would you find that? And we'll talk about that in a minute. So questions on that? That's a little bit of, there actually, it looks like a question came in. Let's see. Something about MSBuild. Yeah, let me come back to that one since we're kind of talking about the Debug Serve piece right now. So, So one of the things that's really cool about the equal language that Endgame's developed is it allows you to sort of, if you're going to use equal, it's a really amazing way to describe and hunt and query. It also can be used, you could think of it as a way for different defensive teams to share detection. So most of you could translate an equal syntax into something that would work in your network. So here you can see a sequence query that describes both the process making network connections or creating child processes. Also, you can see that there's a potential that an adversary might rename that tool. So there you're looking for like the original file name being changed as well. So definitely there's a lot here to go into on equals. So once the slides are the slides are out, but once the talk is published, check out the talk to see how Ross will take you through the methodology of using the equal language. So kind of fun way to describe that. So questions, Mike, so far? Anything coming in? Doing okay?
Yeah, looking good. Yeah, it's cool.
I think I'm going a little bit faster than I thought we would. A couple other things here that are cool about equal analytics as related to some of the tests. So related to atomic red team tests, there's a bunch of equal lib tests or equal lib analytics. So you can see these are a fun way to describe on the left what the attack is. And then that query that we saw earlier can be just contained into this analytics file. And if you're running a set of queries across data set, you could check all of these various tests. I think there's over 100 checks they've got on their analytics library. So that's definitely something to explore. It's a good way for teams to share detections, collaborate, etc. So
yeah, and they're all really easy to write too. That's probably one of the really cool things about SQL is when you look at some of the other ones in there, there's like some really basic queries, and obviously up to the really advanced ones like this, but like you can add your own and then you can share them back. And,
yep. And it's a good way to validate, like, and that's where Atomic Red Team kind of is really complementary to this, is like the SQL Analytics library lets you validate the query. So if you're looking for a child process, you could just definitely validate at least creating some of those tests and confirming, am I actually seeing the right relationship, or am I seeing like the whole ancestry to roll it back up, et cetera. So, okay. So a couple of things then. I'll pause there for questions. So we've looked at two attacks. We looked at one attack, MSBuild. We looked at another attack, Debug Serve. A question did come in about using PowerShell implant that uses MSBuild for evasion. And let me just paste that GitHub link into the, I guess, the chat here, Mike. Let me see. If I answer the question, will everybody see it, or how that works?
I'm not sure, but if you want to just drop it into the chat. Yeah.
All the mechanics here. Hold on. So someone referenced this page, which is a really good GitHub page that has a lot of different attacks. And one of those was like using PowerShell without PowerShell. So you could run PowerShell inside of MSBuild. Yeah, there's some really good stuff there. So good observation. Definitely something to keep in mind.
So Casey, just you had it set to all panelists. I just flipped it to all panelists and attendees. So there again, just make sure it's attendees as well.
Did that go out? Okay. And
yeah, it went out there now.
Webinars are hard. So, okay. Any other questions on that? There's a couple of things then, I guess, if there's no questions on Debug Serve or MSBuild. Let's look at kind of closing some ideas. So like things that you want to think about in your environment. So what developer tools are actually being used? Prevalence is really powerful here. Debug Serve in our searching, we didn't see it used in the last interval across a lot of hosts. So there was even the surfacing that may be something to investigate. And if it is used, like who's using it, trying to couple the user workstation, the username, the path, all of that context that Mike talked about could be helpful. You know, what, by whom, which user, et cetera. A lot of times you hear build a baseline. And so this is something I wanted to call out. So while I know this is specific to CBR, you could look at this and explore it for your tools and things. But Keith McCammon wrote a really cool tool called Surveyor. And that's a way to build your baseline. So if you want to know really quickly, like with that particular tool, how many times has MSBuild run, with what command line, with what parameters, Debug Serve. It's a really cool way to sweep your fleet using the Carbon Black API. So you may have other tools, you may have Sysmon, et cetera. There's things there, but just wanted to call out that's an open source tool that we've published on our repo as well. You can check out. So
yeah, and so everything for Surveyor is just written in JSON. And what I've done in the past is, I think I posted this on Twitter, but you have the ability to create that quick file of everything to look for. So like any kind of lull bins or lull scripts, things like that you want to just run down in your environment. And it's a really fast way to use this. And like Casey said, it will provide you all the command line per endpoint with username. Just a really quick way to almost pretty much hunt and understand what's out there. And you can take that data, put it back into, you know, if you're mapping any kind of rules in like a sim or whatnot, you can go and whitelist things, or at least you know what's happening out there really quickly. So yeah, great way to look at stuff.
Yep, cool. And so with that, it's Friday, people. You're on a webinar. Any other questions? Otherwise, we want to turn you loose a little bit early. Thanks for joining. These, like I said, this is recorded, so those that missed it, thanks for watching later. Any other closing thoughts or feedback for us before we turn you loose?
Other than the fractal globe.
Yes, that is my favorite meme. I use that all the time. It's good times. All right. Well, again, thanks everybody for being on today. We'll keep you posted on next Atomic Fridays. We're open to feedback. I'd also make a pitch. We love to have people present besides us. So if you're using Atomic in a cool, novel way, want to share something, share some research, get some feedback, definitely ping us on the Slack channel, and we definitely will get you in the queue. So it's not just us having the conversation. We could have other folks on this too. So thanks everybody for your time, and I'll close it out if there's no other questions. All right. Take care. Thank you.
Thank you all. Have a good day.